This is synthesis. Blue plus red equals purple. Deposition. An example of this is the Korean Peninsula. It used to be just Korea. Now it is North and South Korea. Single replacement. Here we have a man and a woman, and then we have another woman. The man leaves the woman and heads for the other woman. This is an example of single replacement. Single replacement. Here we have a man, a woman, and another man. The woman leaves the first man for the second man. Double replacement. Here we have a criminal holding a woman hostage. And here we have a policeman with a sack of cash. Notice how they come together and trade the hostage for the money.
Alright, so here we have our periodic table, and we're going to create a equation. For this, let's use synthesis. We're going to use iron 3, which has a charge of +3. Let's have that react with oxygen. Now, oxygen, that's a diatom, which means that it has to be with itself when it's alone. So if we have iron plus oxygen, that comes into itself. Because if we have two of them, they have to become one. That's why it's synthesis. Iron, that is a charge of +3. Let's just put that down there. Oxygen, the charge of -2. So in order for them to come together, it has to be F2 and O3. Now, these are unbalanced, so we have to do something about that. Since that is 2 iron and 2 over here, let's put a 2. And let's take, that's 3, and put a 1 over here. Now, you can't get from 2 to 3, so let's double this and go to 4. And take this and go to 2. Now, there's 6 oxygen on this side, and 2 on this side, so if we add a 3 here, we can get rid of our charges. That's 4 iron and 3 O2. That becomes 2 iron 2 O3. And this would be a synthesis reaction. And the abbreviation for a reaction is simply RXN, reaction. And this is our equation where iron 3 combined with O2.
Single replacement. To show single displacement cationic, we have zinc and hydrochloric acid, also known as hydrogen and chlorine.
Alright, so in the reaction we just saw, there was hydrochloric acid, which is hydrogen chloride, and zinc mossy, or just zinc. Now, in this reaction, we know that hydrogen was produced. That was the gas that was coming up. And hydrogen is a diatom, so H2. That leaves that it would have to be zinc and chlorine together, and that would come together as zinc CO2. That way the charges actually match up. Now, in order to do this, let's say we have 2 hydrogen over here, so I need 2 hydrogen here, which that corresponds to the 2 chlorine over here, 1 zinc, 1 hydrogen. So here we have the reaction being complete, and this is a single replacement, or a single R reaction, and it is, as far as I can tell, cationic.
Wait, so what do we have to do?